Okay, so the next question that we got on the menu today is asking us um, find all of the solutions over the 0 to 2 pi, which is pretty much just like everything within one rotation. Find all those solutions. And we're basically trying to solve for x. And we know that the question that we have right here is sine 2x is equal to root 3 over 2. Okay, so what do we actually know about what has to be going on here? So we know that sine is going to be this is going to be like the opposite over hypotenuse. And root 3 over 2 should hopefully ring some bells, but I'll draw some stuff out to hopefully make the stuff more clear. Okay, so suppose we have a right angle triangle like this. Okay, and then suppose we have a vertical line going right down the middle, just like that. Okay, now maybe I'll switch up my colors. So imagine this side length is 2. This side length is 1, but there's also this side length which is 1. Like you could see it was originally 2, but since we chopped it in half, they're going to be 1 on each side. This is an equilateral triangle. So we know that this got to be 60 degrees, which is another way of saying that is pi over 3. And this is the same deal, 60 degrees. And over here, well, it's going to be 30 degrees here, which is pi over 6. And over here, also going to be 30 degrees, which is also going to be pi over 6. Just radians and degree conversions are really important. So hopefully, you keep your mind right and recognize that you can go back and forth between them comfortably, because it is important. Okay, now let's try to figure out what the hypotenuse here is. No, not the hypotenuse, the height here, like this. So let's just call this h, and we know that 2 squared equals h squared plus 1 squared. Okay, so if we wanted to solve for h, well, we would subtract 1 squared from both sides. And well, let's first expand this out. So we have like 4 equals actually we can do that in one step. So 4 minus 1 equals h squared. So h must be the square root of 3. So this height is a square root of 3. And in which angle would it correspond to if we have the opposite as square root of 3 and the hypotenuse as 2? Well, we would need this angle right here, which is pi over 3. This would be the only way that we can correspond to that. So we know that this has to be sine pi over 3. Which means that since we know that sine pi over 3 is equal to sine 2x, we know that, well, we can get rid of the signs and we'll just have pi over 3 equals 2x, and we can divide both sides by 2 to get x on its own. So we'll have pi over 6 is equal to x. Okay, that's going to be like our base angle, but we have to think about this in the bigger picture, right? So let's imagine, let's draw like some Cartesian grid like this. Okay, so here will be our y-axis, and here will be our x-axis. Okay, so we've already confirmed that pi over 6, this is confirmed because we know that sine of 2 times pi over 6 is equal to root 3 over 2. Okay, but we also got to think about angles that are possibly bigger than 180, angles that are possibly bigger than 90, angles that are possibly bigger than 270. That could also lead to a answer that corresponds to this, right? So let me introduce you to something called the cast rule. So if you write out cast like here, the first letter corresponds to who's going to be positive in these quadrants. So here, there's going to be all positive. Here, we're going to have sine positive, but tan and cos will be negative. Here, we'll have tan positive. And here, we'll have cos positive. Now, we already know that since we're working with sine, these two downstairs are disqualified. Disqualified, need positive sine value. Value result. Otherwise, the result of doing a sine is going to be a negative number, and clearly our answer that we are given is not a negative number. Okay, so we can't really have that. Okay, so we know that somewhere between 90 degrees and 180 degrees, we're going to find that sine times 2 times one of those angles is going to give us root 3 over 2. Okay, so let me let's think about this a little bit more. We want to think about what's going to give us root 3 over 2. And essentially, we're going to be looking for a situation like this, where we're going to have an angle like this. This is what's going to lead us to root 3 over 2. Because this is going to correspond to pi over 3. And because we want pi over 3 to ultimately be on the inside of the sine. Right? Keep in mind the multiplied by 2 inside of the sine kind of complicates things by a little bit. Okay, so if this is what we want, that means that this angle here, this has got to be 2 pi over 3. Okay, so essentially what this means is that sine 2 pi over 3 is equal to root 3 over 2. Ask your calculator. Your calculator should definitely agree with that. And we know that this is equal to sine 2x. Well, if this is the case, I'll write it down here just to be a little bit clearer. Sine 2x is equal to sine 2 pi's over 3. Then we know that x has got to be pi over 3. It's got to be the case. Okay, so our first answer was pi over 6. Our second answer is going to be pi over 3. And we just need to know, like, it has to be, we're looking for the angle with respect to the x-axis. And we're always, like, in the quadrant here, we're going to go clockwise from the x-axis. In the quadrant here, we're going to go counterclockwise from the x-axis. So always make an angle measurement from the x-axis, and you want to make sure that your angles correspond to that. Okay, cool. So our two answers, our first answer is x equals pi over 3. Our second answer is x equals pi over 6. Both of these lead to situations where we can say that sine 2x is equal to root 3 over 2. Okay, typically there's always going to be two solutions for any trigonometric function like this, and a lot of the times you'll be asked to find all of the possible values between 0 and 2 pi, so just stay ready for that. Okay, so yeah, the above solution is good.